How would you find the length of the shortest path of zeros from the top left to the bottom right of an n by n binary matrix? This question has apparently been asked in interviews at companies like Facebook and Amazon, and is a good practice question when preparing for an interview. Whenever you're asked to find the shortest path between two nodes, you should immediately begin thinking breadth first search, because BFS exhaustively explores the search space layer by layer, so it is guaranteed to find the shortest path to a terminal node once it arrives at its layer. We typically implement BFS using a queue. In this case, our queue will hold pairs of indices. The first index is the row number and the second index is the column number. While the queue is not empty, we'll extract the first element and add all the indices of the adjacent cells to the queue. In this problem, we're allowed to move in 8 directions, so we'll loop 8 times, and in each loop iteration, we'll calculate the indices of an adjacent cell. To move down, we'll add 1 to the row number and 0 to the column number, and to move right, we'll add 0 to the row number and 1 to the column number, and so on. When we calculate all the indices adjacent to 0, 0, we notice that some of them fall outside the boundaries of the matrix. These need to be filtered out, so we'll only add pairs of indices to the queue if they fall within the boundaries of the matrix. Secondly, in order to ensure that we do not reprocess the same cells over and over, we need to keep track of already visited cells. One way of doing this is by declaring a Boolean 2D array of equal dimensions, and when a cell is visited, updating the corresponding cell in the Boolean matrix to true. But while the new matrix ensures no cell is reprocessed twice, it holds no additional information to help us find the shortest path. So let's use a 2D integer array instead, and initialize all values to -1. When we start traversing the original matrix, we'll set the value of the top left cell to 1, and the value of every processed cell after that will be 1 plus the value of the previously processed node. At the end of the grid traversal, we'll return the value at the bottom right corner of the grid. We are only interested in the shortest path made up of zeros, so if we encounter a 1, we won't continue processing that cell, and to ensure we don't reprocess it, we'll set its length from the start node to the maximum integer value, which we'll denote as infinity. Finally, we need to make sure our solution covers all cases. If there's a valid path, we'll return the shortest length. If there is no valid path from the top left to the bottom right of the grid, we'll return -1. And if either the top left cell or the bottom right cell is a 1, we should also make sure to return -1 instead of infinity. Putting it all together, we get a solution which beats 86% of submissions on time and 83% on memory. If you enjoyed this video, don't forget to like and follow if you haven't already.